Hey, Algebra 2, today I'm going to teach you how to complete the square. So what does that mean? It means we're going to go from having a quadratic that looks like this in standard form over to one that looks like this, which looks like vertex form. So that's what our plan is today. So in order to do that, we have to find what we call perfect square trinomials. So this is an example of a perfect square trinomial. So let's go ahead and make an ACB chart and factor this. So when I take A times C, I need factors of 9 that add up to 6. So 3 times 3 is 9, and that in fact adds up to 6. So I would factor this as x plus 3 times x plus 3. So anytime you have a perfect square trinomial, the point is that these two factors are exactly the same, and you can write this instead as x plus 3 quantity squared. So that's what a perfect square trinomial is. So we're going to learn how to create these so that we can rewrite them in this format. All right, so this one should be one as well. So apparently it doesn't matter if there's a plus sign there or a minus sign there. What is important is there does need to be a plus at the end of both of these. So when I make an ACB chart, I'm looking for factors of 25 that add up to negative 10. So negative 5 times negative 5 is positive 25, and that in fact does add up to negative 10. So this factors as x minus 5 times x minus 5. So since these are the same, we can rewrite this as x minus 5 quantity squared. So we're going to have to sometimes create our own perfect square trinomials. And so in order to do that, you take b over 2 and you square it. All right, so there's an invisible 1 there, so there's my a, there's my b, and I'm trying to figure out what number would this have to be a perfect square trinomial. So I take 22 divided by 2 squared, which is 11 squared. And I know that that's 121, but I'm not really going to, which equals 121. So x squared plus 22x plus 121. So if it says find the value that creates a perfect square trinomial, that would be the answer. And so let's factor this to make sure. So I need factors of 121, my bad, 121 that add up to 22. So 11 times 11 is 121, and that adds up to 22. And so if these are the same, that's how I know that I can just rewrite it and put it like that. So anytime these factors are the same, you can just write it with the appropriate sign and square it. All right, so I'm trying to figure out what C should be. So there's my A term, there's my B term, and then there's C. So you take b divided by 2 and you square it. So in this case, it's negative 4 divided by 2 squared, which equals negative 2 squared, which equals 4. So if that was the essential question, what value completes the square, the answer would be 4. So if you do x squared minus 4x plus 4, if you made an ACB chart, you need factors of 4 that add up to negative 4. So you get negative 2 times negative 2 equals positive 4, and that does in fact add up to negative 4. So since these are the same, I know that this is just going to factor as x minus 2 quantity squared. And we have a few more. You can try those on your own and check the notes in class. Sorry. There we go. So now we have an equation, and we would like to solve each equation by completing the square. So it says A must be 1. In this Algebra 2 course, A is always going to be 1, and pre-cal it will not, and if you took honors it would not. It says isolate the x squared and x terms and move the junk to the trunk. That means on the other side of the equal sign. Okay, so we need to move 11 to the other side. Have x squared plus 10x. I'm going to go plus blank equals 11 plus blank. So I'm trying to figure out what this amount should be right here by doing what we did on the prior two problems. But now I have an equation. So the only way to keep an equation in balance would be to add the same thing to both sides. All right, so there's my A and there's my B term. It says you take half of B and you square it. I'm going to get rid of that right there because I don't want you to think that that's a subtraction sign. So I have 10 divided by 2 squared, which equals 5 squared. I'm going to leave it like this because it'll save us a step in a minute. All right, so we added that to each side, and now we're going to factor it. So I leave it like this because whatever this number is right here, that is how this always factors. So this factors as x plus 5 quantity squared. So over here on this side, you could either just put it in your calculator like that, or you could go ahead and change that to 25 if you wanted to. But 11 plus 25 equals 36. So we would like to solve for x. A long time ago we learned that in order to get rid of an exponent, you take the square root of both sides. So I'm going to take the square root. The radical cancels out that exponent, and I get x plus 5 equals. When you take the square root of a number, you get two answers, both a positive and a negative. And the square root of 36 is 6. So I need to write two equations. One of the answers is x plus 5 equals 6, and then the other one is x plus 5 equals negative 6. Now I'm just doing algebra, and I'm going to solve. X equals 1. Subtract the 5 over. And x equals negative 11. All right, let's do one more for the video. All right, so it said isolate the x squared and x term. So I have the x squared and x on one side already, so I don't need to move anything around. There's my A term, there's my B term, and all that's on the other side. So I'm just doing B divided by 2 squared. That minus definitely means you need to write that as a negative 4. That is negative 2 squared. This is what I'm going to add to each side of my equation. X squared minus 4x plus negative 2 squared equals negative 1 plus negative 2 squared. So whatever number you have here, that is always how this factors. So this factors as x minus 2 quantity squared. So if that B term is a negative, you should see that negative continue on through right there. And if you have a positive, then we have a positive that carries through. Let's see, negative 2 squared is 4, and negative 1 plus 4 equals 3. So now I want to solve this, and I'm going to take the square root of each side. That cancels that out. I get x minus 2 equals plus or minus radical 3. So in this problem, 36 was a perfect square, so I could take the square root of it. 3 is not a perfect square, so I'm going to leave it alone. I'm not going to do a decimal or anything. I do have to solve for x, so I'm going to add 2 to both sides. And when you have an integer and a radical, it would be more normal for the integer to go first, the plus minus, and then the radical comes second. So that is how you complete the square. No, let's do one more. Let's do number 11, because we have a negative number and we should definitely, an odd number. All right, so my first move is to move the 7 to the other side. All right, so I am going to try to figure out what I need to add to both sides of this. My formula up there says you take b divided by 2 squared. And there's nothing to simplify there, and so this really is just b divided by 2 squared. Because when you factor this, this factors as x minus 5/2 squared. I put all this in my calculator earlier, so maybe you used negative 5/2. Maybe you changed that to negative 2.5. Some people might like a decimal better. And let's see, that is 25/4. Pause. I'm sorry, I did not feel good about that answer, and so I double-checked it, and that is negative 3/4 actually. Okay, we're going to move on now. I would like to solve for x, and so I need to get rid of my exponent. I'm going to take the square root of both sides right now. The radical and that exponent cancel each other out. I get x minus 5/2 equals, okay, so we learned a long time ago, the square root of a negative is I. I cannot take the square root of 3, so I still have that under the radical. But now I also would like to take the square root of the denominator, 4, which is 2. And I get 2 answers, so I still have my plus minus there. I would like to solve for x, so I'm going to add 5/2 to both sides. And so x equals 5/2 plus or minus I radical 3 all over 2. So that is not the most lovely answer, and you cannot graph it, but that is definitely a good answer. Check the rest of the notes for the others.